Hello there, myself Jatin Jain. I'm studying in University of Glamorgan doing B.Eng Aeronautical Engineering, and the fifth question I'm going to answer is about trigonometry. It is very useful in the real world as well because plenty of real world applications from any structures of bridges are made from truss structures, and we use these trigonometry rules in order to calculate the forces, the moments and the angles in the truss structure, because it is very important to know, because everything in the bridge depends on that. And the figures which you will see on your screen now is a prime example of how we used trigonometry in the truss, how truss looks like, and you will see it is quite similar to the triangle at the moment on your screen. As you can see on the screen, this is the prime example of truss. See, all these bits are made up of truss. This is a HSBC building, and you can see how trigonometry works here. If you don't know this, the balance of the structure of the building is on these trusses, on these structures, on these bars. The forces, the stress, the strain, all values should be needed, and trigonometry works in there because you can resolve the components of forces, and you can check the angles, then you can calculate the values of them. So it is very important application, and you can easily judge how more we are using this in the real world. If one building is made of this truss structure, then plenty of bridges all over the world are made from truss. Fifth question I'm going to answer is about trigonometry, how trigonometry works with the right angle triangles. And it states, in the following diagram, AB is equal to 17.5 meter, DC is equal to 19.6 meter, angle at D from BDC is equal to 27 degree, and angle at C from DCA is equal to 90 degree, which is at right angle triangle. And this is the rough sketch of the figure. Calculate the size of ADC angle at D. So according to right angle triangle formulas of sine, cos and tan, we know that in case of sine, cos and tan, we have formula opposite, adjacent, opposite, hypotenuse, hypotenuse and adjacent. This is the thing you need to remember that. So whether we given opposite and hypotenuse, then we can use sine formula, and when we given adjacent and hypotenuse, we can use cos, and opposite and adjacent we can use tan. So in right angled triangle BCD, so in this small triangle BCD, here this is C, this is T, this is B, this is given 27 degree, and this is 19.6, and we don't know this. So basically here we are using opposite and adjacent. So we can use tan formula according to this chart. So tan 27 degree is equal to BC over DC. If we put the values in, so tan 27 degree is equal to BC we need to calculate, and DC we have 19.6. Therefore BC is equal to 19.6 multiplied with tan 27 degree, and by using calculator you can calculate the value of tan 27 degree, then multiply with 19.6. it will give you 9.99 meter, which is approximately 10 meter. Which further means now we know that AC in this diagram is equal to AB plus BC. AB we already have 17.5 and BC we calculated 10. So AC is equal to 27.5 meter. So now in right angled triangle ACD, which is that one, this is C, this is D again, this is 19.6 given, we know this is 90 degree, this is A, and now we calculated this 27.5. So again we have opposite and adjacent, so we can use tan formula again. So tan, because we need to calculate the angle this time, so tan theta, we call this total angle as theta, is equal to, theta is a Greek word, AC over DC. Tan theta is equal to 27.5 over 19.6. we can write down theta is equal to tan inverse 27.5 over 19.6, and by using your calculator we can calculate the value of tan inverse, the fraction which we have. So theta is equal to 54.5 degree, which is similar to A D C is equal to 54.5 degree, and that's your answer. So basically, if any triangle, right angle triangle is given to you, you need to work out which side is given, whether it is hypotenuse, opposite or adjacent. According to that you can use sine, cos, tan formula, but it only applies when the triangle is right angle triangle.